What's up, everybody? It's Count James, and welcome back to the channel. Today, we're diving deep into the fascinating world of database query syntax. Yeah, you heard that right. We're talking databases, the engines behind the apps and services we use every day. Now, you might be thinking, databases? That sounds boring. But trust me on this, things are about to get really interesting. We're going to explore how different databases aren't just about storing data. They're about expanding the range of questions we can ask of our datasets. Think of it like this. Each database is like a different language, each with its own unique way of expressing queries. And just like learning a new language opens up a whole new world of communication, mastering different query syntaxes can unlock incredible insights from your data. So buckle up, because we're about to embark on a journey through a veritable petting zoo of databases. First up, we've got Druid, a beast of a database built for handling massive amounts of time series data. Think of those real-time dashboards you see with constantly updating charts and graphs. That's Druid's bread and butter. But what really makes Druid stand out is its query syntax. It's designed for speed and flexibility, letting you slice and dice time series data in ways you never thought possible. And to visualize all those insights, we're pairing Druid with Superset, an awesome open-source visualization tool. Superset is like the artist to Druid's data canvas. It takes those raw queries and transforms them into stunning dashboards and visualizations. And the best part? Both Druid and Superset are completely open source, so you can dive in and start exploring without breaking the bank. We'll be taking a look at some real-world examples of how Druid and Superset are used together to power everything from business intelligence dashboards to scientific research platforms. You'll see how Druid's unique query syntax lets you ask complex questions about your data, like, what was the average website traffic over the past hour, broken down by geographic region. And with Superset, you can visualize those results in interactive charts and graphs that make the insights jump off the screen. Whether you're a data scientist, a business analyst, or just someone who loves playing with data, Druid and Superset are a powerful combination that you need to check out. Next up, we're stepping into the world of enterprise-grade analytics with Snowflake and Tableau. Snowflake is a cloud-based data warehouse that's known for its scalability and performance. It's like the luxury sedan of databases built for handling massive datasets with ease. And when it comes to visualizing all that data, we're turning to Tableau, a leading data visualization and business intelligence tool. Tableau is like the master chef of the data world, taking those raw ingredients from Snowflake and transforming them into a feast for the eyes. With its intuitive drag-and-drop interface, you can create stunning dashboards and reports without writing a single line of code. Now let's talk query syntax. Snowflake uses a variant of SQL, the industry-standard language for querying relational databases. But here's the cool part. Snowflake's SQL implementation is optimized for the cloud, with features that make it blazing fast and incredibly powerful. We'll explore how Snowflake's query syntax lets you perform complex joins, aggregations, and window functions to extract meaningful insights from your data. And with Tableau's visualization prowess, you can bring those insights to life with interactive dashboards and stories that are both informative and engaging. Whether you're a seasoned data analyst or just starting your data journey, Snowflake and Tableau offer a seamless and powerful solution for unlocking the full potential of your data. Now, for all you SQL lovers out there, let's talk about TimescaleDB. This database takes everything you love about PostgreSQL, the workhorse of open-source relational databases, and supercharges it for time series data. Think of it like adding a nitro booster to an already fast car. TimescaleDB achieves this magic through a clever concept called hypertables. These hypertables act as specialized tables, optimized for storing and querying time series data within PostgreSQL. But here's the best part. You still get to use SQL, the language you know and love, to interact with your time series data. TimescaleDB extends SQL with specialized functions and clauses specifically designed for time series analysis. We'll dive into how TimescaleDB's query syntax lets you perform time-based aggregations, interpolations, and even gap filling, all within the familiar SQL environment. Imagine effortlessly querying for the average temperature over the past week, downsampled to hourly intervals, or identifying periods of high website traffic with just a few lines of SQL. That's the power of TimescaleDB. So if you are already comfortable with SQL and want a database that can handle your time series data without breaking a sweat, TimescaleDB is definitely worth a closer look. Chapter 4. InfluxDB, Riding the Functional Wave of Time Series Data. Get ready to surf the functional programming wave with InfluxDB, a purpose-built time series database designed for high-volume data ingestion and lightning-fast queries. InfluxDB takes a different approach with its query syntax, embracing the power of functional programming with its query language, Flux. Flux is all about treating queries as data transformations, allowing you to chain together functions to manipulate and analyze your time series data in a highly expressive way. We'll explore how Flux's functional paradigm lets you perform complex aggregations, windowing operations, and even mathematical transformations on your data with ease. Imagine calculating the rate of change in sensor readings, smoothing out noisy data points, or performing statistical analysis on your time series, all within a single elegant query. This functional approach might take a bit of getting used to if you're coming from a traditional SQL background, but trust me, the flexibility and power it offers are well worth the learning curve. Chapter 5. RethinkDB, where JSON meets query power. Next, we're venturing into the realm of NoSQL databases with RethinkDB, a database that embraces the flexibility and scalability of JSON documents while providing a powerful and intuitive query syntax. RethinkDB is like the Swiss Army knife of databases, able to handle a wide range of data models and use cases with its flexible JSON document store. But what really sets RethinkDB apart is its query syntax, which borrows heavily from the world of JavaScript and functional programming. RethinkDB queries are constructed using JavaScript objects and functions, making it incredibly intuitive for developers familiar with JavaScript to pick up and use effectively. We'll explore how RethinkDB's query syntax lets you traverse complex JSON documents, filter and transform data, and perform aggregations with ease. Imagine querying for all users who have liked a particular post or finding the average rating of products in a specific category, all with a few lines of JavaScript-like code. If you're looking for a database that can handle the dynamic nature of modern applications and provides a developer-friendly query syntax, RethinkDB is definitely worth considering. Chapter 6. ElasticSearch, the search ninja of the data world. Prepare to be amazed by ElasticSearch, the open-source search and analytics powerhouse that's become synonymous with finding needles in massive haystacks of data. ElasticSearch is built on the concept of inverted indexes, a data structure that allows for incredibly fast full-text searches across vast amounts of data. But ElasticSearch is more than just a search engine. It's also a powerful analytics platform with a query syntax that's both flexible and expressive. ElasticSearch uses a JSON-based query language called QueryDSL, or domain-specific language, to interact with your data. This DSL provides a rich set of operators and clauses for filtering, aggregating, and analyzing your data in ways that traditional relational databases can only dream of. We'll explore how ElasticSearch's query syntax lets you perform fuzzy searches, geolocation queries, and even aggregations over time-based data. Imagine finding all documents that mention a specific keyword within a certain proximity to a given location, or analyzing trends in customer sentiment over time. That's the power of ElasticSearch, and it's no wonder it's become the go-to solution for everything from log analysis and application search to business intelligence and security analytics. Chapter 7. Neo4j, Unveiling the Power of Relationships with Graph Databases. Get ready to think differently about data with Neo4j, a graph database that excels at storing and querying relationships between entities. Unlike traditional relational databases that store data in rows and columns, Neo4j uses nodes, relationships, and properties to represent data as a connected graph. This graph-based model makes it incredibly natural and efficient to represent and query relationships between entities, such as social connections, product recommendations, or financial transactions. Neo4j uses a powerful and intuitive query language called Cypher to interact with your graph data. Cypher is designed to be human-readable and expressive, allowing you to traverse and query relationships with ease. We'll explore how Cypher's pattern-matching capabilities let you uncover hidden connections, identify influential entities, and perform graph algorithms to gain deeper insights from your data. Imagine finding all friends of friends who have visited a particular location, or identifying the most influential people in a social network, all with a few lines of cipher code. That's the power of graph databases like Neo4j, and it's revolutionizing the way we think about and interact with connected data. Chapter 8. OrientDB, the Multi-Model Mastermind. Hold on tight as we explore OrientDB, a multi-model database that combines the best of multiple database paradigms into a single, powerful platform. OrientDB is like the ultimate data chameleon, effortlessly adapting to different data models and use cases. It supports document storage, graph databases, key value stores, and even object-oriented concepts, all within a single unified system. This multi-model approach gives you incredible flexibility in how you choose to model and query your data. OrientDB uses SQL as its primary query language, making it familiar and accessible to developers coming from a relational database background. But don't let that fool you. OrientDB's SQL implementation is anything but ordinary. It's been extended with specialized functions and operators to support its multi-model capabilities, allowing you to seamlessly query across different data models within the same query. We'll explore how OrientDB's query syntax lets you traverse relationships in your graph data, perform full-text searches on your documents, and even execute transactions across multiple data models. If you're looking for a single database that can handle the diverse needs of modern applications, OrientDB's multi-model approach is definitely worth considering. Chapter 9. TypeDB, the Knowledge Graph Alchemist. Get ready to enter the matrix with TypeDB, a database that takes knowledge representation to a whole new level. TypeDB is built on the concept of a knowledge graph, a powerful way of representing information as a network of entities and relationships. But TypeDB goes beyond traditional knowledge graphs by introducing the concept of a type schema, a formal schema that defines the types of entities and relationships that can exist within your knowledge graph. This type schema acts as a blueprint for your knowledge, ensuring data consistency and enabling powerful reasoning capabilities. TypeDB uses a unique and expressive query language called TypeQL to interact with your knowledge graph. TypeQL is designed to be highly declarative, allowing you to express complex queries in a concise and intuitive way. We'll explore how TypeQL's reasoning capabilities let you infer new knowledge from existing data, identify patterns and anomalies, and even perform complex simulations. Imagine querying for all instances of a particular concept, finding all entities that satisfy a set of constraints, or even simulating the impact of changes to your knowledge graph. That's the power of TypeDB, and it's pushing the boundaries of what's possible with knowledge representation and reasoning. So there you have it, a whirlwind tour through the amazing world of databases and their unique query syntax capabilities. From time series powerhouses like InfluxDB to the graph traversal magic of Neo4j, we've seen how the right database can unlock incredible insights from your data. By leveraging these diverse databases and their unique query syntax capabilities, we can unlock new insights and possibilities. Each database is like a specialized tool, each with its strengths and ideal use cases. The key is to choose the right tool for the job, the one that best aligns with your data model, query patterns, and performance requirements. Stay tuned for more deep dives into the world of data and technology. And as always, thanks for watching. Peace.